task that we would normally use for the beginning of our maths session, which is called our daily number sets. So in every classroom you would see that as a beginning, roughly 15 minutes to the maths lesson, and that's where they're building up their number sense and their ability to use numbers flexibly. So we're going to begin tonight with a number talk. So when I reveal the number talk, the process that we've been doing these in Year 4 since the beginning of the year, the first thing that they do when the number talk is revealed is that they have thinking time. And it's generally around 3 to 4 minutes of thinking time. When they come up with a solution, they have their fist on their chest and they just raise their thumb. But the beauty of a task like this and the extra time that they are given to perform that task is that as they are sitting there, if they are able to come up with a second solution, they raise another finger, and if they're able to come up with a third solution, they just keep raising their fingers as they come up with more solutions. And it's kind of bringing in that notion of creativity in maths, and that you can be creative in maths. Not creative as in visual arts creative, but creative as in coming up with lots of solutions to solve the one problem, which can often be more valuable than solving 5 different problems. So I'll reveal it, and then you'll hear silence as the students have their thinking time. And as Nick discussed in the hall, try and restrain yourself from jumping in straight away if you see them struggling a little bit. We'll be coming around as the teachers, just like we would in the classroom, to support those if we see that they need it, and also if we see any red cups as well. But generally they'll have their own independent thinking time first.
Parents, you're obviously welcome to have a go at this. You're encouraged, in fact, to have a go. See how many ways you can come up with to answer this problem.
You're listening, because when we pull out the sticks for solutions to record on the board, it will actually be you giving your child's solution to the problem. One more. Two more.
Last minute cancellation. Ethan, D. Are you here?
Oh.
Sorry, D.
Ethan, 20 times on a 25 metre book, so he's figured out that 4 times 100.
Hang on.
Yeah, so he knows it's 4, 4, and 16.
It knows it's 4, 4,
Yeah.
and 16.
Yeah.
So then you have to multiply the 100 by 4. So I don't know how you draw that, but
We add those all together. All right. One more.
One more.
One more. It's still one I'm looking for, Mr. Horton.
What you'll see Christie's Mrs. Costa's expertly doing here is providing a visual, a diagram every time to make sense of the working out. So whilst we do want children working mathematics in their heads and having multiple ways of doing things, numbers for kids at this age are essentially abstract, and the more we can represent them visually, the better their understanding. Abby, are you here? Susan,
Yes.
can you explain just what Abby did?
Okay. So Abby went 20 times 25 is 500, and 4 times 25 is 100, and subtracted.
Oh, I like it.
Nice.
Cheeky.
Great, I like the thinking. All right, there's one more still, but I might just...
Well, Chappelle. So one of the things we find with the paddle pop sticks is that kids who want to answer all the time do eventually get frustrated with it. So once we pull a few people out to make sure everyone's paying attention, we generally say, has anybody got
Is
anything
there
else
anyone else?
that they would like to share that we haven't already seen? Kalani, you got one there? Chappelle, I'll come to you in a moment.
Big boys, can you stand up for me too, maybe just so I can hear you better?
10 times 25. Which gives me 250. And then 6 times 25. And then equals 150. And then you added those two together and that equals 400.
Nice. So,
brilliant.
Kalani, yours is similar to Avril's, except you split the 25 and not the 16. Is that right? Very good. So what the kids are doing here, this is called partitioning. So this shows that they've got an understanding of place value. They're splitting their ones and their tens, and we could get more involved. We could do hundreds. And if the kids have the ability to split those numbers up and see how they're made, they can employ a massive range of strategies to get an answer.
And this is what demonstrates the range of flexible thinking that the students develop when they use mental strategies and do number talks in the classroom frequently.
All right, Chappelle, last one from you, and then we'll go on.
I did it in formal algorithm, and so I did 25 vertically underneath, and then there was a 16 underneath that, and then
We did old school.
Old school?
Yeah.
Okay. All right.
There is still one more, Mr.
Well, I've
Horton.
got one. I reckon it's one you haven't been told of.
Oh, really?
Unless it is your one.
What is it?
Right, have I got a pen?
Yep, good luck finding some space.
Ready for this? I doubled the 25 to make 50, half the 16 to make 8, and did an 8 multiplied by 50 is 400. What I actually did was 8 multiplied by 5 to get 40, and then I just carried my extra 10 across. Was that the one you were thinking?
It was Mr. Horton.
There we are. All right, thank you very much.
At this point, because we're under a bit of
The
a...
numbers they're really dealing with. So we want all of these to underpin the formal algorithm. We do still teach it, but all of this happens first, and they've got a sort of sense of reasonableness for whether or not they're right with their answer. Now I'm going to put a problem up here. Parents, I'm going to ask you to have a go as well. Okay, so I've got some digits missing. I'm missing a digit here, here, and here. Now this is what's known as an open task, because there's more than one answer that we can have. Now it's also known as something that's differentiated, because if a child just gets one solution to this, if they come up with one digit here, and one here that makes that work, they've been successful. If they come up with two, they're doing it even better. If they come up with three, they're flying along. If they come up with all of them, I'm going to want to know how they know they got all of them. So something that appears initially as quite a simple task is accessible at different levels. And if you think you've got all of them this evening, I'm going to ask you how you know you've got all of them and whether or not you work systematically. Begin.
Getting this fabulous working out. I get so excited about numbers.
But what about there's more than one?
Could be 2 plus 20 plus 30.
What other number could we make that ends in a 0?
Can I use zeros? Do zeros count? 30, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1, 2, 3, 4, 5, 9. Is there any more after that?
I'm finished. I'm finished.
Yeah.
Which one would be?
It can be 50.
I have one.
Can it be 54? Why?
Princesses are up That's what I got.
How can you check that you've got it all? How do we know? How can you be systematic?
I voted. Because there wasn't a 5, 6, 7, 8, 9. We need that counts to 10. There's actually, because they all equal 60. Well,
Because the unknown is this one, and this one, and this one. These two. So we've got 2 possible answers.
We found all the way down the numbers in the pattern. No, but it's not. Have a think about it. It's going to change the answer, isn't it? But it's still going to be. Keep working, Dad.
Thank you. Now, Ben's come up with 10 solutions there. 10 solutions. He's done extremely well. I'd be pleased if he'd come up with one. He's got 10. He thinks he's got them all. The question I'm going to ask to the room now is, did anybody find a pattern? Was anybody able to find a pattern when they started working this out that enabled them to work systematically?
Shall I pull a stick, Mr. Horton?
Pull a stick. If you've got your hand up and you found a pattern, you might be able to come up and show us what it was.
Kalani.
Did you find the pattern, champ? Alright, here we go. Alright, so Ben's got 10 solutions. we're going to see if you've got 10 using your pattern. All right, come on over, mate. I'll write them up for you. All right, Ben 10. All right, what have you got? Oh, okay, you better read those out to me in order. 30 plus 20 equals 50. Is that right? Is that better? Thank you. Go on. 39 plus 21 is 60. Yes, go on. Keep talking.
38 plus 22 equals 60.
Go on.
37 plus 23 equals 60.
Anyone see a pattern emerging here on the board? Yes. Carry on, Carly. You might be onto something.
36 plus 24 equals 60.
Okay.
35 plus 25 equals 60.
Go on.
34 plus 26. 33 plus 27.
Hang on. Sticking with that. 33 plus 27 equals 60.
33 plus 20
And what's your pattern? Okay, so Kalani's telling me that his pattern goes 9, 8, 7, 6, 5, 4, 3, 2, 1. Should have that at the bottom then, and 0. And 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Give me a little show of hands if you manage to see a pattern and work systematically there. Okay? So again, I'm very pleased if anyone managed to reason through the answer. If you manage to find more than one solution, amazing. If you could systematically arrange and work it out using what we call number bonds to 10, that's something the kids learn in year 2, actually they start learning in kinder, and apply it here, that shows the progression of learning. I'm very, very pleased with that. You've done very well. Sit down. You've done very well. Well done, Ben. Here's an exit ticket.
You go on before your ticket. It's totally.
Thank you very much. So, I'm sure you can imagine that at any point in any class, or actually in reality, there's a 5-year spread of ability in any primary school classroom. It gets more pronounced as kids get older. And children come to school with quite a lot of prior learning. So, any time a teacher assumes that every child in the class doesn't know,